Welcome everyone, and thank you very much for making the time once again to get together to discuss OPC. This, of course, is our fourth webinar of the OPC UA Inside Out webinar series. We are now in the second half of the series, with two more webinars to follow after this one. We have a packed house again today, and for the first time, the majority of the attendance is from the end user and industry community. And rightly so, as this is the only webinar where we talk about an OPC product, while the other webinars were and will continue to be around the OPC technology at large. My name is Anand Taparia. I take care of marketing here at Utthunga together with my lean but a very power-packed team. As a quick recap, we have covered the following in the earlier webinars in this series. The first one was on the basic elements of OPC UA. Then we covered the relevance of OPC UA in embedded and low footprint devices. In the third one, which was the last one, we dived into edge devices. In case you missed any of these or would like to recap, all the recordings are in our YouTube channel. Simply search for Utthunga in the YouTube search bar, and the first link that you see is us. There you will see all the recorded webinars, including the old ones. Today's webinar is titled OPC Tunneller. Actually, the webinar is going to cover tunneler or tunneling at an even higher level. That is, implementing tunneling between applications with OPC and also without OPC. For anyone asking, what the hell is tunneling? Well, our speakers will surely answer that as well, and then they will build upwards. Next slide, please. Just a quick brief about Utthunga. We are an industrial software and hardware services company, partnering closely with OEMs in the industrial world to build products and solutions from concept all the way through the life cycle of the product. Be it enabling field devices, assets to be smart, or building configuration calibration software, or highly sophisticated software and hardware systems. We leverage our rich pool of engineers to co-build products and solutions with our customers. We offer services in application development, embedded services, IIoT, and verification and validation. Our services are targeted to OEMs and end industries in process, factory, and power domains. Next slide, please. Great. These are a few industry bodies we closely associate and work with on protocol and connectivity. Protocols form the foundation of how we started as a company, that is connecting field devices and field assets to the hardware and software systems up in the value chain. Our association with these consortiums, and importantly the OPC Foundation, is rooted in our commitment to build interoperable industrial systems. With that, I would like to introduce our speakers for today. Next slide, please. Thank you. Thilak. Thilak is a software architect, a seasoned one actually, at Utthunga. In terms of his OPC credentials, Thilak is an active member and contributor to OPC Foundation PubSub Working Group. He is also an active member of OPC UA Specification Working Group in FDT Consortium. Thilak has strong knowledge on DDS, IoT connectivity, protocols like MQTT, AMQP, and other protocols. Thilak is also responsible for developing and certifying the OPC UA server that Utthunga built, Utthunga's own OPC UA server. He is also a specialist in troubleshooting OPC UA and DA connectivity and integration issues. Loves to get into the chair of tech support and talk to our customers in the field to help troubleshoot their issues. Next slide, please. Mahantesh. Mahantesh is an OPC specialist with 5 years of experience in OPC-related software development. He is also an active participant and contributor to the OPC UA specification working group and is deeply familiar with the OPC UA client-server architecture and various OPC UA stacks. Mahantesh also has extensive experience in various IIoT communication and industrial protocols like Modbus, HART, BACnet, Ethernet IP, MQTT, AMQP to develop cloud-based solutions. Just a few administrative points before we get started. The duration of this webinar is 60 minutes, which includes a demo as well. We will utilize the last 10 minutes for questions from you. Please send in your questions using the Q&A icon on the left side of your screen. The slides of this presentation and a link to the recording of this webinar will be emailed to everyone post the webinar. I also request you to click on the full screen icon, again on the left hand side of your screen, to get a good view of the slides. Before I hand over to Thilak, our first speaker, a quick poll will appear on your screen. Request you to please participate. I'll wait for 30 seconds before closing the poll. Okay, I shall close the poll now and share the results with you. So we have a majority of folks joining in today, most of whom are of course from the industry community, have a varied mix of OPC Classic and UA applications in their plants. And of course, tunneling helps there to connect these applications. Very few say they are very comfortable with DCOM, and which is actually reality. With DCOM rolling out of new updates of Microsoft and of course the settings or the reboot of a computer, these issues keep coming. And tunneling again helps even connect the classic applications, the OPC applications to each other. So with that, I would now like to hand over to Thilak. Over to you, Thilak.
Yeah. So thanks, Anand, and thanks everyone for participating this webinar. So in today's webinar, we will be discussing more on OPC Tunneller. So with that, an introduction on OPC client-server architecture, where most of the time we use the tunneler when you want to connect an OPC classic client and server are running in different machines. And also the DCOM challenges and the DCOM settings when we perform when we won't use tunneler. So then followed by an tunneler basics, so which is how tunneler looks like and the definition of the tunneler, and followed by OPC tunneler protocols, where we can achieve the tunneler using OPC UA standard interface, as well as an proprietary interface. We have taken one of the example as REST service TCP IP. Then we'll also walk through with one of the use case with the central monitoring system, how you can achieve it using a tunneler. And followed by, we will give a brief on how to choose a tunneler with the features and the benefits when as an end user. Then followed by a demo of an OPC UA based tunneler. Then we will finally have an Q&A. Right. So about OPC Classic, as we know, OPC server, which internally have and drivers which will connect to PLCs, DCS, or the controllers, which collects the data and exposes in one format called OPC. So once you have an OPC client which is running in a same machine, then it uses an COM-based technology to establish the connection, expose the data. So if an OPC client is running in another machine in a remote location, then it uses an DCOM configuration to establish the connection with the OPC server. Hence, in this case, you will be having, or you need a DCOM setting, the DCOM configuration to establish the connection. So though we have a limitation of OPC classic client server like platform dependency, where it can work only on Windows, and it has a limited security, and you have an interoperability issues across the drivers network, lack of support of complex data types like hierarchical data types, where in case of OPC UA it supports the latest version. So without using OPC Tunneller, so generally what end user does to do the DCOM settings. So you need to go to component service and you need to provide the permission for launching, activation, and the remote access, either for the specific user or the everyone. And also you need to provide permission for the OPC server COM object as well as OPC enum to discover the server. So once you have done it, you have to restart the computer, and some of the need to maintain the conditions like you have to have a same login password combination of both the computers, and you have to ensure the computer are part of the same domain or the work domain network, and you have to confirm that OPC enum is running, and you have to disable the firewall, or if not, you need to add an appropriate programs and ports to the exception list so that the firewall will not block. Sometimes even after you perform these DCOM settings, you will be still facing some challenges, like your DCOM configuration got reset after you are restarting your computer, which means that one of the solution is your Microsoft updates might be turned on, and that might be resetting your settings. So you need to reset, you need to set it to off state so that the DCOM configuration may not get reset. Second issue might be the computer is not listed, but the IP address is pinging still. So which means that there is an option called network discovery. You should be in on state. So unable to find OPC server. In this case, you may need to restart the OPC enum service. And also you may need to check, verify the OPC enum DCOM permissions to ensure that the OPC server is getting discovered. So to get rid of all these challenges, one of the solutions we used to recommend is to use the OPC Tunneller. So this generally avoids the DCOM configuration, and also you can access through firewall protection. So by enabling the data by adding the appropriate programs and ports to an exception list and overcome the DCOM challenges. So next is about Tunneller basics. So how Tunneller looks like. So one end, you will be having an OPC classic client enabled applications like HMI, database, etc. On the other end, you will be having SCADA, DCS, which is enabled with OPC classic servers. So we will be deploying a server-side component which will be communicating locally with the OPC classic server, having an OPC client as a driver, and there will be one wrapper. The other end, it will be having a client-side component where it will be having an OPC proxy classic server which connects to an HMI application locally, and it will be having a protocol driver which can communicate to a wrapper through firewall. So the definition of OPC Tunneller, we would say it enables the seamless communication between OPC classic client and OPC classic server running in different machine by eliminating DCOM configuration. So when we say protocol driver, so So there are two ways where we have an tunneler basics with internal and external OPC tunneler. So this will be mostly explained by Mahantesh. Mahantesh, please go ahead.
Yeah. Thank you, Thilak, and thank you everyone for joining this today's session on OPC Tunneller. So, as a continuation of the tunneler basics, we will see the types of OPC tunneler. So, basically, there are two types of or two ways to achieve a tunneler. So, one is internal OPC tunneler, and the second one is external OPC tunneler. So, first, let's see what is internal OPC tunneler. So, in internal, all the transactions called local OPC transactions will occur at asynchronous manner. So, whenever there is a request from the client to the server, it responds back to the client immediately from the local cached copy. So, here the data transfer between the client and the OPC client program is a little bit faster. And so for the best example is for data monitoring based on the subscription interval. So next we will see on the external OPC tunneler. So here all the transactions in the external OPC will happen at a synchronous manner. So on the typical OPC client request is across the network to OPC server, and the server will respond back to the client in and one after the other. So here the user may face or user may need to wait for the response gets back from the server. For example, read and write operations will occur at extended OPC transactions. So little bit. So external OPC is a little bit. OPC transactions are a little bit slower than the internal OPC tunneler. So next slide, please. Okay. So here we will see. So OPC tunneler protocols using OPC UA and the REST service as an example alternative to OPC UA. We will see, can we achieve a OPC UA, OPC tunneler using only OPC UA? No, we can also have a REST service as an example protocol and along with OPC UA. Next slide, please. Okay, so here the REST service. So basically, in the OPC tunneler, if we use a REST service, so it becomes an the proprietary implementation and the customized as per the requirement with related to data format exchange between the client side component and the server side component. Yes, of course, it is a lightweight data transfer due to the way we the design of the data may be using a JSON format or the XML format, and also it enables remote access and the local connectivity across the firewall connections. And so with related to data security, yes, it's an inadequate or a less secure when it is compared to OPC UA protocol with related to encoding, authentication, token, and the various informations available for the security features. And the diagnostic information may not be available in the server side components due to the payload, the design of the overall payload, and it doesn't allow industry standards due to the proprietary implementation of the data format, and hence we may face a difficulty, or it seems a difficulty in integrating the third-party components with the server-side components. And due to this reason, so IoT 4.0 cannot be easily we can achieve using REST service. Next slide, please. Okay, so here, so let us understand. So one standard, so OPC UA standard, how we can have in the OPC tunneling. So before that, let's understand what is OPC UA. So OPC stands for Open Platform for Connectivity, which is built on the OPC client and server architecture, where client will request the data from the server regardless of the protocols in a standard address space. So it affiliates to international standard IEC 62541, and so OPC UA is developed and maintained by OPC Foundation and recommended by RAMI 4.0 for Industry 4.0, which is a reference architectural model industries. And so OPC it has its own security objectives, which adds some more value to OPC UA protocol. The first one is authentication, where it provides an authentication using username and password. It provides authentication with the certificates of type X509, and it also provides authorization, where user can authorize to do a particular service operations or a set of nodes or a set of read-write operations. And it also provides a confidentiality, integrity with a lot of security features like security mode and the security policies, and due to encoding technology, so to avoid the tampering of the data. And it also supports auditability and the availability of the data and the server all the time. So next, so OPC UA security mode provides none, sign, and the sign and encrypt. So wherein none, the data will not be encrypted. In the sign, data will be signed using X509 certificate, and in signed and encrypt, data will be signed and encrypted using various algorithms like basic 256, basic 128 RSA15, defined under the OPC UA security policies. So let's see now the advantages of OPC UA classic over a classic. Yes, OPC UA has an advantage over a classic server, where it will eliminate where you don't need to have a DCOM configuration, a standard communication over the internet using IP address and the port number, and it protects against unauthorized data access using username, password, and certificate-based authentication. And also it provides the data security and the reliability due to its the standard way of defining the both request and the response data format. And it is a platform independency and the scalability, because it is not dependent on any particular operating system like Windows or Linux based operating systems. So you can have this OPC UA protocol enabled in across all the platforms. And so it also supports a simplified use of across the computer using a client which is affiliates to standard OPC UA specifications, from connecting to reading the data in a subscription model. And also it supports complex data structures, like when we have multiple nodes which are related to each other, then all the nodes we will contribute into the one node, so that we can see all the data in one node. Next slide, please. Okay, so let's see OPC UA protocol in OPC Tunneller. So it's a standard implementation as per the specification provided by OPC Foundation, and also it enables the remote access and local connectivity across the firewall connections. And of course, it has a more data security compared to a REST service which we took in the previous slides. And here one more important thing is that it is having the diagnostic information at the server side components. For example, we can have a number of clients connected to server side components. We can have a number of subscriptions available, number of parameters available in the subscription. So like this, we have a lot many diagnostic information available to the user. And we can easily integrate with third-party components with the server-side components with the various standard OPC UA clients. And hence, we can easily achieve 4.0 IoT. So next slide, please. Yeah. So the next section will handle by Thilak.
Yeah. Thanks, Mahantesh. So next is on use case, central monitoring system. and also we'll be speaking on how it gets connect with IoT application. So assume that you have an SCADA application installed in different sites or the different networks, say site 1, site 2 till site n, and you have an HMI or an any OPC client enabled application which is installed in the main control room of the centralized location. So all you can use is you can have an OPC classic to OPC UA converter, which is, as we told, as a server side component. And of course, it will come across the firewall, the switches, and of course, the different networks. Since it's an OPC UA with a secured connection, you can expose all your OPC classic data from this SCADA. So which will be connected to a client-side component where you'll be having an OPC UA client driver with the OPC proxy classic server, so that all your HMI's database can be easily connected, and you can do the operation as per your need. Since it is exposing data in OPC UA format, you can also just connect to our IoT cloud platform, where you can further extend to your mobile application or the web applications. So benefits are where you can achieve it to centralized data access in a secure, scalable, and reliable communication from their locations. And you can also control and monitor all of their geographical centers from the remote locations. And it reduces the cost factor by eliminating the need for ripping and replacing the existing legacy devices. So next, how to choose a tunneler. So as a end user, when I'm choosing a tunneler, so there are some basic features and benefits which should be looking for. And so basically it should support data access, alarm and events, and HDA features with compliance to OPC specification. And it should eliminate the permission issues encountered across domains and work groups. And it should enable the OPC classic data transfer through firewalls by eliminating the use of DCOM. It should overcome OPC timeout issues and disconnections caused by DCOM. And it should also have the security by encrypting the data between OPC classic clients and servers to provide data privacy. And it should also have some feature like supporting user-based access by filtering the tags based on user credentials. And when a new tag is getting injected in OPC classic server, it is supposed you should eliminate the tunneler reset, and it should appear on the browser automatically. And you should also have an option for diagnostic information to troubleshoot. In case if you're not able to establish the connection, you should be knowing why it is not getting connected. Also, it should support OPC classic DA version 1.0 connectivity. So it should support an automatic reconnection between the server and the client, so that the end user will not keep checking whether the connectivity is happening or not. And of course, it should be a cost-effective and customizable as per the customer requirements. So let's quickly go to a demo with OPC UA based tunneler. So OPC server is running in one of the machine. I have taken a remote access, and an OPC client is running in another machine. So I'm using a third-party OPC classic client, and I have not performed any DCOM configuration. So I just go and connect. So since I have not done DCOM configuration, you can see that there is an error occurred using an COM service. So So now we are using one of the Tunneller server component. I can just yeah. So now I'm going to add an OPC classic servers. So currently it is finding the available computers in the network. Yeah. So when I double click on the computer, it identifies the OPC servers that are running in that particular computer. So I'm choosing one of the third-party OPC UA server, which is of type data access, and I can provide the name for that, which will be exposing in OPC UA format. So I would like to add some more servers which exposes data as an OPC AE, alarm and events. Now I'm adding an OPC HDA server, which is from OPC Foundation. So I also add another DS server. So this Utthunga's UOPC Tunneller server, a server-side component, has a feature to filter the access based on the users. So here you can see that it lists all the available users based on the domain. So currently I use my user. I select my user and I just give permission only to the servers that I need to browse it. So only the admin user can able to select the servers. So now I have provided the access for the specific servers. So once the configuration is done, I'm just saving the configuration to ensure that it takes the latest configuration. All right, so the server-side component has been configured. So now we will quickly move to an client-side component. So now the system that is where we are running the client-side component, it's actually in the different domain. So if in case the computer is not getting listed, we can add the computer manually. On double click on the computer, you can see that the OPC UA server which is running, it will automatically discover and it will be displayed with all the endpoints that are available for that server. So I choose the security mode as sign and encrypt with basic 128 RSA15 security algorithm, and I provide the username and password. Right. I would like to add another instance of the same tunneler server with a different credential, where we can see the difference how the user based the tags are getting filtered. So we give the admin rights. Right. So now I'm saving the configuration. So this is simple steps where you can configure the client side component, where it generally converts the UA data to OPC proxy. So now I'm using the third-party client, where you can see that an proxy server is already get listed here. So now I'm connecting the OPC server, which supports as DA, data access. Yeah. So the first UOPC Tunneller server, which is listing, where I can see that I can able to access the tags of kep_DA. However, I didn't provide the access for matricon_DA and I'm not able to see the tags. However, for the UOPC Tunneller server _1, I have logged in with different credential with admin rights, where it has access for all the tags. So in this case, I'm able to see the tags which belongs to matricon. So which means that you can filter the tags based on user credentials. So now I'll quickly browse the tags. Yeah, and select few tags for the subscription. Yes, so now you can see the values are getting updated with good quality. Similarly, we also have an OPC Tunneller client, which sees all the events which are exposed from the underlying OPC server. Yeah, so now we have connected an third-party server where DAAE alarms has been exchanged to OPC UA, and OPC UA again it has been converted to OPC AE. I will open another application where you can read the history data. So now I'm connecting the Utthunga's UOPC tunneling client component, which supports HDA. So I say read raw with maximum of 1000 tags, which reads last 10 minutes of data. Yeah. So whatever the data which is in the underlying HDS server, so that it is bypassed through OPC UA and it is exposing data. So to ensure that it also it is connecting through OPC UA, we use an sample OPC client provided by the OPC Foundation. So now I'm logging with my credentials. Yes. So since it's a standard OPC UA client, so OPC UA server with compliance to OPC UA, we are able to connect and browse the tags. And we can also able to read the data. We can also do history processed for every 1 second interval. Right. So this proves that you can, without doing DCOM configuration, you can easily exchange or transfer the data from one system to another system using OPC UA component. So next is it's time for audience Q&A.
Thilak, you want to pick up from, or should I read it out to you?
Yeah, I have a question. I can able to see.
Sure.
Yeah. So the first question is, I have 7 independent DCS network not connected to each other, and all are having OPC server, and each network in IP range of 192.168.x.x and having firewall. How do I get all the OPC data in one server in a centralized location? Yes, it is achievable. This was even which I have explained in one of the use case in the presentation. So all you need to do is you can use the server side component in each DCS network, where all the classic data it can be converted to OPC UA, and hence the other end you can have an centralized with the client side component, which we can connect all the OPC UA servers, and then you can the output of the client side component of the proxy server you can be used for further user interface like HMI's application. It can be connected. So the next question is how the licensing of Tunneller is done. So it's up to an vendor who provides the Tunneller. So generally, since you'll be deploying the Tunneller in both the machines, so you will be you may need to activate the license in both the computers. So the next question is Tunneller license transferable to another PC if the running PC fail? It's up to the tunneler product that you choose. Technically, yes. So until you have an licensing information, so if the license is transferable from one machine to other machine, you can transfer it, or else you need to speak with the vendor and get the new license. So the next question is, OPC UA server should be in OT network or IT network? So technically, OPC UA can sit in any platform or any layer. It is not restricted to OT network or the IT network. So it can be placed in both the platform. So it can be run in OT as well as IT. So the next question is, timestamp in HMI and server is same or lag? So technically, since it is exchanging the data from one component to another component, that is from actual OPC server to an server side component, then from server side component to client side component, then followed by an HMI. So there will be an lag in the timestamp. However, the OPC, when it is giving the data, it will be exposing data along with the timestamp at what time the data was read. So based on that, user should be able to take the actions. So the next question is, so what is the validation process to be followed? Okay, I think as per my understanding, the question is that, okay, so when you're choosing the tunneler and when you're configuring what validation you need to be done. Yes, certainly when you are establishing the connection between the OPC UA, you need to ensure that the certificates gets exchanged from one system to another system, and yes, and you have to ensure that the IP address is getting pinged. And also, if you are looking for the validation in terms of the product, so basically, as I mentioned in the presentation, you need to see certain features, and where it suits your requirement, then you can choose it. So the next question is, do we need to install client on HMI2? Generally, most of the HMI applications come with OPC classic client interface support, and sometimes even it comes directly as OPC UA. So if you have an OPC UA client, it's already inbuilt available, then you no need to have a client side component where you can directly connect the server side component. If you don't have it, then you need to install the client side component. So then only you can, it will become a local connectivity, and without doing any DCOM configuration, you can establish the connection easily.
Thilak, there's one at the top that may have got missed, and I'll just read the question to you. What ports are used to scan network machines? This is from Chetan. He's asking what ports are used to scan network machines on server side and client side when it browses available machines.
Okay, so when you say port, it's up to the application which uses. So and it will be a configurable port. So based on the port availability, the OPC server which is running. So that will be exchanging data or OPC in that port. So generally, even if you are using an Utthunga OPC Tunneller, it uses 9091. But it depends. Like if that's the port is already used by another application, then we can change that port number and it can be configurable.
There's one from Prasad. He's asking if the software is 21 CFR Part 11 complied. Now, what I can, and I'll just jump in, Thilak. I think what you're asking is, of course, this pharma compliance, 21 CFR. We are OPC standard, but not in this we comply with that. The pharma explain later on by an email as to if it really is required to CFR compliant, because it's really not safe data, it's just a pass through literally. So we can get back to you on detail via email. That has come as a follow-up from Anil Parab. He says, how to install client on Linux HMI?
Generally, so this client-side component, which uses the COM-based technology, so which works only on Windows. So generally, you may not able to run it for Linux-based HMI system. So it's only for Windows-based application.
Okay, one last question. It is, does Tunneller reduce performance?
So it's up to the I would say the number of tags that you are monitoring. So technically, yes, but it's not as huge level of reducing the performance. There might be a delay because there's the number of components, it is exchanging from one component to another component. There might be a delay, but maybe in terms of milliseconds.
Okay, so let's stop at that, Thilak. Anything that, at this point, I think we've answered most of the questions. If people do have additional ones, feel free to email us, and we'll be more than happy to answer those via email, like how we've been doing for all the older webinars, responding to the questions via email also. So before we close, I just wanted to take a few more minutes of your time once for a quick poll question. It'd be very nice if you could answer the next question appearing on your screen. Okay, I'm going to stop now and just quickly share the results. As expected, because majority of the people, of course, here use OPC applications in different form factor. So there is, and now with OPC UA also adding to the mix, so tunneling does seem to be a requirement for most people. Please feel free to reach out to us. We will also reach out to you if there's any way we could help out for your needs around OPC. Before we close, just wanted to talk about the upcoming webinars also. Firstly, thank you everyone once again for your attendance. We hope it added to your existing knowledge of tunneling. We would, of course, love to get your feedback. Please do share. We will be sending in out the feedback question shortly. Based on the feedback we have received over the last 3 webinars, we've actually tweaked our approach and content to better address your needs. So we hope to receive more again this time as well. Finally, a quick peek into the upcoming webinars. Next slide, please, Thilak. Thank you. In fact, before I forget, for anyone of you or your colleagues who are into field device integration, we also have a sequence of very targeted webinars coming up on FDT DTM technology. In fact, the first one is starting next Thursday. Stay tuned. Our LinkedIn page, Utthunga's LinkedIn page is the best place to get the up-to-date information, but we'll of course reach out to you as well. Now, in terms of the upcoming webinars on the OPC UA Inside Out series, the next webinar is on the role of OPC UA in IIoT. In the entire value chain, from the origin, the source of data, to the final consumer of that data, or rather information at this point, once it reaches a final destination, it's not data anymore. OPC UA has significant role to play. And the next webinar talks more about OPC UA in IIoT. In the last webinar of the series, we cover the connectivity challenges in brownfield projects and the importance of implementing OPC UA in new greenfield projects. Request everyone, please block your calendars. We'll be sharing the registration links end of next week. Do follow us on LinkedIn and YouTube. Just search for our name, Utthunga, Utthunga, on LinkedIn. By the way, most people may not know, Utthunga is a word for pinnacle. Please search us on LinkedIn, current information. Thank you very much. See you all on June 24th. Stay safe. Thank you.